A new big blue gas cloud seen near Andromeda, the galaxy we thought we knew well enough. How come we never discovered it before? Hundreds of telescopes, both on the ground and in space, have been used to explore the sky. Yet even with this extensive study, we still have much more to discover. As evidenced by the recent finding of a gas cloud near the Andromeda galaxy, the sky still has many secrets to unearth. For decades, this cloud went undiscovered, and its origins remain unknown. There's still much to uncover. Thanks to the affordable yet outstanding quality of digital detectors, astronomical photography is now simpler than ever. This has brought about a new trend among astronomy enthusiasts to concentrate on a particular part of the sky and take exposures that are comparable to long-term exposures, with the goal of discovering any faint fuzzies that reside there. Keep watching to learn more about this astonishing discovery. In this picture, we see Andromeda, and above it, we observe a blue ghostly figure. What is that? It's a very unusual and intriguing discovery from the nearby Andromeda galaxy. This discovery was made by independent astronomers Marcel Drechsler, Xavier Strautner, and Jan Sainty back in 2022. They use simple techniques such as applying different filters and observing the same spot for a long time, a concept known as long exposure, to find something that had previously been missed by other surveys. They decided to focus their efforts on the Andromeda galaxy, a spiral galaxy similar to the Milky Way, located 2.5 million light-years away, that has been studied by astronomers for over 100 years. With its most notable features already mapped, they believe that any leftover discoveries would be smaller, individual elements such as nebulae in the galaxy itself. While doing this, they accidentally came across an object outside the galaxy. At first, it didn't seem to make sense because it was too big to be associated with Andromeda. It appeared to be an unusual arc stretching further away from Andromeda and was only revealed after a 160-hour-long exposure using the 4-meter-long Canada-France-Hawaii telescope with a 400-megapixel camera. This object was confirmed by independent observations, which revealed it to be an oxygen cloud or arc, or now known as M31 Oxygen Emission Arc, or Strautner-Drechsler 70 Object 1. Sainty shared his findings with Drechsler and Strautner for them to examine and analyze. As they carefully looked at the pictures, they were astounded to discover a large and elongated structure, almost as large as the Andromeda galaxy right adjacent to it. When Sainty used a filter to capture images that only let through the blue-green light from doubly ionized oxygen atoms, atoms that have lost 2 of their outer electrons, a common phenomenon in giant gas clouds, the nebula was made visible. The use of this filter was largely due to his curiosity, as it was the first time a large-scale map of the sky around Andromeda has ever been created. During the same observing session, Sainty took deep images using a different filter that was sensitive to light from hydrogen atoms. He noticed many gas clouds in the vicinity of Andromeda, most likely nebulae from our Milky Way in the same region of the sky as Andromeda, but there was nothing that matched the size and shape of the rare oxygen-rich nebula. The team questioned if the cloud in Sainty's images was some sort of abnormality, such as refracted light from his telescope. To verify this, the researchers requested that renowned amateur astronomer Ray Falls observe the cloud with his own telescope. Falls likewise observed the nebula, confirming it was real. Observations from 5 telescopes located in France, California, and New Mexico ultimately persuaded the team that the object was real, thus leading to its nickname Strautner-Drechsler Sainty Object 1, SDSO-1. But I'm sure you're all still asking yourselves, what is it though? After seeking expert advice, the findings of the collaboration between Robert Fesson, Michael Schul, and Stefan Kimswinger, and amateur astronomers, was published in the American Astronomical Society's Journal Research Notes of the AAAS. Although tantalizing, the origin of this nebula remains very elusive. This photo of Andromeda, captured in visible light with red, green, and blue filters, is stunning. Yet there is no evidence of the large cloud known as the Stroessner-Drechsler-Sainte Object 1, SDSO-1. Investigation of various hypotheses has been concluded by astronomers, yet the gas cloud remains unexplained. Its close proximity to Andromeda in the night sky suggests a connection, and its curved shape suggests that it is bulging from the galaxy. Although these features do not definitively prove a bond between the cloud and the galaxy, they certainly indicate one. If SDSO-1 is indeed part of, yet outside of, Andromeda, this would mean the cloud spans a length of tens of thousands of light years and would become one of the largest coherent structures that Andromeda has. If the cloud is located in Andromeda's colossal halo, a broader circular swath of stars encircling the galaxy, it might be composed of the gas thrown away by the stars it contains. However, since the stars are mainly composed of hydrogen, then there should be plenty of hydrogen visible. But as Sainte proved with his hydrogen detecting filter, there was not enough to be seen. SDSO-1 lies between the Milky Way and Andromeda, which may provide insight into the interaction between them. As they pass each other in space, their individual halos may be bumping into each other, compressing any diffuse gas into a curved bow wave, similar to that from a boat moving through the water. If this were the case, the cloud should be situated roughly halfway between the two galaxies rather than just near Andromeda, and this still does not explain the absence of hydrogen. It is possible that the cloud is actually much closer to us, being a nebula in the Milky Way, and merely appears to be in the Andromeda galaxy. These planetary nebulae are made up of gas discharged from dying stars that are mostly composed of hydrogen and oxygen. This makes them appear illuminated as a result of light emitted by these two elements. However, the absence of hydrogen in SDSO-1 is still strange. It is conceivable that SDSO-1 might be the survivor of a Milky Way star which detonated like a supernova. However, it ought to be incandescing in ultraviolet light and radio waves. The researchers nevertheless observed no radiance from the nebula at any other wavelengths, such as X-rays, visible and infrared light, when looking through archive photographs of Andromeda. No existing explanation covers all of the available facts, and it's certainly puzzling. But that's also what scientists find so exciting. We became researchers to work on puzzles, and this is one that we're eager to solve. It's amazing that SDSO-1, a celestial body as large as 3 full moons, was only recently discovered considering the narrow field of view of large telescopes. Astronomers aren't entirely surprised, though, because the bigger instruments couldn't spot the object. They couldn't see the big picture due to focusing in too closely. SDSO-1 is very dim, making it difficult even for professional observatories to detect it. The discovery and confirmation images using the doubly ionized oxygen filter took 160 hours to capture. The 3.8-meter Canada-France-Hawaii telescope, which has an impressive 378-megapixel camera and oxygen filter, looked directly at the area in the sky where SDSO-1 lies, and still couldn't detect it. This is because the telescope is not designed to observe objects that are large and faint. Using spectroscopy to break up the cloud's light into wavelengths, the velocity of the gas in SDSO-1 can be identified by studying the blue shift or red shift of its color. If the cloud is moving at a similar speed to Andromeda, then it's probably associated with that galaxy, while a slower speed could mean it's part of ours. Research is ongoing, so the origin and behavior of this cloud remains mysterious for now. SDSO-1 may be puzzling, yet it is also a sign of optimism. It proves that there are still multiple fascinating objects in the cosmos yet to be discovered. All we have to do is use the correct approaches to reveal them. In the research paper they published in January of 2023, they explained that sky surveys that use optical emission lines can be very helpful in recognizing different types of emission nebulae, like H2 regions, planetary nebulae, supernova remnants, and wind-created cavities and outflows from stars. Most of these surveys focused on detecting H-alpha, the brightest hydrogen line emission along the galactic plane. Now that cost-effective, high-sensitivity CMOS detectors and narrow passband filters with high transmission have become accessible, non-professionals can be seen making a larger contribution in recognizing emission line nebulae, not only around the galactic plane but also in other places. They were able to conclude that the curved filamentary structure seen in the emission arc could be a high-latitude galactic supernova remnant, a planetary nebulae near the Milky Way, or related to the giant stellar stream in M31's halo. Further spectroscopic observations are being done to establish an association with M31. Before moving on with the possible explanations, be sure to stay tuned afterwards if you haven't seen the collision between Andromeda and our galaxy has started. Nobody knows what this object is, how far away it is, what produced it, if it is even in the Andromeda galaxy, or how big it is. One potential explanation is that it could be related to the future collision of the Milky Way and Andromeda galaxies in the next few billion years. Some of the gas from the halo of Andromeda and the Milky Way has already started to interact, creating the arc-like shape. However, this object is in the wrong location for that theory to be true. Another explanation is that it is much closer to us and much smaller than expected, making it part of the Milky Way instead. At this point, there is no single explanation for what this cloud is. It is faint and difficult to see and contains no hydrogen, unlike typical planetary nebulae or stellar streams. Scientists are now working to get more data, such as the Doppler shift, in order to determine where the cloud is located and what it is. Hopefully, within the next few months, we will have answers about this object. It is a huge mystery and one of the biggest discoveries for independent astronomers in the last few years.
So what Hubble actually discovered and was a tight relation between the redshift of other galaxies and their distance from us. This, of course, translated into the well-known Hubble's law we've already mentioned. But what does it mean? What was this tight relation? He found that the more distant an object was, the more shifted its spectral lines were, and they were shifted to the red part of the electromagnetic spectrum. Usually, astronomers don't take photos. They analyze the stellar spectrum. That is, they study the division of light coming from a stellar source. This light is characterized by lines that cross the whole spectrum, and these lines contain crucial pieces of information about stellar composition, density, gas, kinematic, and so on. That was an empirical law that turned out to be very useful, because one just needed to know the correct value of the Hubble constant in order to find the distance of any object in the sky. You had a telescope, so you had the redshift, that is the displacement of lines with respect to the laboratory-obtained lines. You had the redshift, Hubble's relation was telling you the distance of your source. It seemed an easy trick, too good to be true. So a Doppler shift towards the red part of the spectrum means the object is getting away from us. On the opposite side, a blue shift in the lines of stellar object means it is approaching us towards the line of sight. It is now that we are finally ready to talk about galaxy collisions. Soon after Hubble, astronomers began to study the objects in the sky and take as much redshift information they could. Because of the expansion of the universe, the vast majority of objects in the deep universe were found indeed to go away from us, at some speed determined by Hubble's law. But something strange was happening. Some objects didn't seem to care about Hubble's law. Some objects were simply going towards us. The question was, why is that? Apparently, these objects were violating Hubble's law. Did they? Well, the answer here is that nature is not a joke. Everything has an explanation. Even the weirdest behavior can be explained if you study and think more about it. This strange behavior that characterized some stellar objects was due to the gravitational attraction of the objects. I mean, once we know Hubble's law, we can't suddenly forget about Newton's gravitational law. What I am trying to say is that yes, Hubble's law isn't fake, but it just works better with objects that lie at a very long distance from us. For nearer objects, we found that the gravitational pull is stronger than the acceleration rate of the expanding universe. This means that from time to time, in a world of redshifted objects, we can happen to see some blue-shifted ones. These, as we've already said, are objects that are coming towards us. It's not magic, it's just gravitational attraction that overcomes the expansion of the universe. Well, then astronomers pointed their telescopes to the Andromeda galaxy. They clearly saw its spectral lines were blue shifted. This can only mean one thing: our galaxy was on a collision course. In roughly 4.5 billion years' time, the Milky Way will smash into the rapidly approaching Andromeda galaxy, and astronomers are still attempting to predict what it will be like when the two galaxies collide. Anyway, such Doppler shift measurements can only tell you about the motion directly towards or away from the observer, working out if we were in for a direct hit or a near miss, therefore required careful study of the motion of Andromeda's satellite galaxies, and they reveal Andromeda's trajectory makes collision inevitable. Don't worry, there's no need to be scared, and I'll explain why to you later in this video. For now, let's talk about how this collision will look like. Plugging this information on the relative velocities, estimates of the masses of the galaxies, and details of their structure into the model, the authors of an interesting paper on this galactic collision have watched the event unfold. Though the details depend to some extent on the galactic structure and in particular on assumptions we make about the halos of dark matter that contain the visible disks of the Milky Way and Andromeda, the general picture is clear. First, there will be a series of close passes lasting something like billions of years. At each passage, the structure of the two galaxies will be distorted by tidal forces of gravitational potential. All of these passes will end up in a beautiful merger of the Andromeda galaxy and the Milky Way galaxy. As of today, astronomers observed a bunch of ongoing collisions between galaxies. For example, take a look at this image. It shows the object known as NGC 34. It definitely seems this galaxy looks a bit weird in shape. The main cause for this galaxy's odd appearance lies in its past. If we were able to reverse time by a few million years, we would see two beautiful spiral galaxies on a direct collision course. When these galaxies collided with one another, their intricate patterns and spiral arms were permanently disturbed. This image shows the galaxy's bright center, a result of this merging event that has created a burst of new star formation and lit up the surrounding gas. As the galaxies continue to intertwine and become one, NGC 34's shape will become more like that of a peculiar galaxy, devoid of any distinct shape. In the vastness of space, collisions between galaxies are quite rare events, but they can be numerous in mega clusters containing hundreds or even thousands of galaxies. As in the case of NGC 34, the result of the collision between Andromeda and the Milky Way will be a new, larger galaxy. But rather than being spiral like its forebears, this new system ends up as a giant elliptical. An elliptical galaxy is a type of galaxy with an approximately ellipsoidal shape and a smooth, nearly featureless image. The study authors have named this new galaxy Milkdromeda. What would you call it? Let us know in the comments below. However, we already said that you don't need to be scared. First of all, you'll die long before that happens. But even if you happen to find the long life elixir and be here in 10 billion years, you don't need to be scared. Here's why. While the Andromeda galaxy contains about 1 trillion stars and the Milky Way contains about 300 billion, the chance of even two stars colliding is negligible because of the huge distances between the stars. For example, the nearest star to the Sun is Proxima Centauri, about 4.2 light-years or 30 million solar diameters away. To visualize that scale, if the Sun were a ping-pong ball, Proxima Centauri would be a P about 1,100 kilometers or 680 miles away, and the Milky Way would be about 30 million kilometers, 19 million miles wide. Although stars are more common near the centers of each galaxy, the average distance between stars is still 160 billion kilometers or 100 billion miles. That is analogous to one ping pong ball every 3.2 kilometers or 2 miles. Thus, it is extremely unlikely that any two stars from the merging galaxies would collide. But what will be the solar system's fate according to this scenario? Well, predictions say that the solar system will be swept out 3 times farther from the galactic core than its current distance. They also predict a 12% chance that the solar system will be ejected from the new galaxy sometime during the collision. Such an event would have no adverse effect on the system, and the chances of any sort of disturbance to the Sun or planets themselves may be remote. Also, by the time the two galaxies collide, the surface of the Earth will have already become far too hot for liquid water to exist, ending all terrestrial life. that is currently estimated to occur in about 3.75 billion years due to the gradually increasing luminosity of the sun. This video ends on a melancholic note. The authors estimate of the 10 billion years for the merger to reach its end is longer than in previous studies, but means that the sun will not live long enough to find a home in the new galaxy. Isn't it beautiful? We can't predict what will happen in the future, even if we won't be able to actually see it happen. What a time to be alive. That's all for this video. Thanks for watching, everyone. The Andromeda Milky Way collision is something we will miss. Do you feel sad about that? Let us know in the comments below. See you next time on the channel.